is Mark, and I am gonna show you my surrounding before I do my homework 1 video. What's on my table is the open doc showing me the problem statement. Now I'll get a new piece of paper and start working on this. So as we can see in the problem, it shows us a graph of position. Using this, I'll get a, I actually don't have a ruler, so I just use a pencil for it. Over here, we can see in the given statement that we can calculate the velocity of the wave using equation v wave equals to square root of tension divided by density. And since both are given constants, the top is 0.8 Newton, the bottom is 2 kilogram divided by 10.0 meters. And we don't really need to calculate it as density, we can just put it here as. Finishing up the calculations, this would give us 2 meters per second. Because on the bottom, it's essentially 1 divided by 5, and dividing something by 1/5 give you 5. It's the same as time 5. 0.8 times 5 is 4, taking the square root, you get 2. Now, with this metric in mind, we now know that it will take 0.5 seconds for the bead to start moving. So now we can start drawing the actual graph for time versus height of the bead. So starting at 0.5, it starts moving. And then we can start calculate out the velocity of the bead from this position. We know that the bead is having a maximum velocity of 0.1, meaning that since the front slope of the position graph is steeper, that would be the maximum velocity. During the 0.5 seconds, it has a maximum velocity of 0.1. So it's gonna give us the distance it traversed by a reverse calculation. I will write down everything and show you in detail. As we can see here, So we know that v beat is delta y divided by delta t. Delta t in this passing period could be calculated as the total distance traversed divided by velocity of the wave, which is going to give us half a second. And then plugging these values, we'll get the height, maximum height, the beat reach in y-axis would be 0.05 meter. Then we can plug this into the graph, and here it will give us from 0 to 0.5 and 0.5 to 1. Now, over on the other side, as a descent, we don't actually need to calculate anything. We know that for this distance, it would take 1 whole second to get to the bottom from the position graph, because it would take 1 full second for the wave's descending part to traverse through the beam's location, the beat's location. So it would just be simple as this, going from 1 to 2, descending. The slope over here is going to be half of the slope on the left, which is going to be 0.05. Yes, this is correct. From here to here, this too. And then afterwards, it just travel in, well, the wave travels through the beats, and from 2 seconds to 3 seconds, the beat will not be moving. This is because the total length of the rope is 10 meters, and within this 1 second of time, there's no way that the wave travel to the end of the rope and then come back to it. Actually, you know what? We should draw a graph to test that. Let's say by the 3rd second, it moves 2 seconds per meter. After 3 seconds, it will move starting from 6 meters in total, so it will just reach the other side. This is the position of the beat by this is position graph of the wave and the beat by the 3rd second. So as you see, it just come to the end and haven't got the chance to travel back yet. So this will be the comprehensive graph that's asked in the question, with the maximum height being 0.05 meters. I will leave the graph here for a few more seconds. And that will conclude my homework video for today. Thank you for watching. Have a great day.